Hi everyone and welcome back to Line. Today we are going to work on a great project, non-rigid registration. Last week we saw together how to perform a rigid registration. The goal was to estimate a transformation matrix which is a 4x4 array containing a rotation part, 3x3, and a translation part. Now the problem is completely different. We need to estimate a displacement field. In order to add this displacement field to the source point cloud, and get the local deformation to the target point cloud. To do so, we are going to use the Coherent Point Drift algorithm. And we are going also to use the PyCPD package. So now let's load the two point cloud, the fish target and the fish source, from the original repo of the PyCPD package. Let's plot them together and see what we want to do with them. We have the source fish in 2D and we want to estimate the local deformation in order to get the target fish. We have exactly the same number of points, which is 182 points for both of them. We need to add the displacement field to each single point from the source fish in order to get the source fish to aligned with the target fish. So because we want to work with 3D, what we are going to do is in fact to double the point cloud which is in 2D and to add 0, 0 as a coordinate for the z-axis for the first source fish, and the second one will be with 1 on the z-axis, and they'll concatenate them together, and the same process for the target fish. So let's do that now together. So x1 is in fact, x1 is the np.0 of the fish target.shape 0 and the fish target.shape 1 plus 1 dimension. Okay, so meaning that I just create a 0 matrix for having the last coordinate of z with 0, and the same thing, and we just fill the xy coordinate by the fish target values. Same thing for the 1 matrix with the 1 at the end, and then we just concatenate them together. So let's see exactly what we get. As we can see here, we get the x with the xy values, and for the z coordinate we get 0 and then 1. Okay, exactly the same process for the y. We have 182 points, values from the target fish, and for the z-axis we have 0 and then 1. So it's great. Let's plot them together to understand what we do. Okay, so we have now in blue the source, in red this is the target, and this is now, we just double them, and this is now our same object in blue and our same object in red in 3D. The goal is to estimate the displacement field in order to get aligned the blue one with the red one. So to do that, we use the deformable registration from the PyCPD package. The x is always our target and the y is always our source when we work with this package. Okay, this is great demonstration of the PyCPD package, Coherent Point Drift algorithm, for performing the non-rigid registration. So now let's just understand it. What is exactly the displacement field? We need to, first of all, to initialize our source point cloud, and then to perform the expectation maximization algorithm. The expectation step is used to compute the probabilistic correspondences P, and the maximization step is used to solve for the W, which is the weight matrix. Then we need to just update the original point cloud by adding to the original point cloud G.W, when the G is a Gaussian kernel controlled by the beta, and the W is a weight matrix controlled also by the regularization term. So let's see now, when we have the reg, okay, we can see here that we can find our W, we can find also our G, which is here, and if I want to transform my original point cloud, I can do that. can go inside my function, and I saw transform point cloud is in fact ty, which is a transformed y, equal to y plus np dot of g, which is our kernel, and w, which is our weight matrix. So let's do that, and now let's plot them together. Now we see that the original point cloud, which was in blue, is now in green, and it's completely aligned to the red one, to the target one. So we just computed, very great, the displacement field. We applied the displacement field to the original point cloud, and then we get it completely aligned with the red one. So that's it for today. I hope this video was clear for you. Thank you for following me. Thank you to continue subscribing to the channel. Thank you to share it in LinkedIn. And let's go ahead with the next video next week, deeper in mathematically for Coherent Point Drift and great other project in 3D computer vision.